Welcome back. Let us look at the sixth rule of indices. Rule 6. Let us look at the rule 6. So the rule 6, we shall look at fractional indices. We shall look at fractional indices. So let's see what we can learn from this rule. So far we've dealt with integer powers, both positive and negative. Now what if we have a fraction as a power? So if we have a fraction as a power, for example, if we have a to the power 1 over 2, so we've dealt with positive and negative integers. But what if now we have a as a to the power 1 over 2? So let me use the right color here. So we have 1 a over a to the power 1 over 2. Now we know that, so I want us to explain the meaning of this power. So we will first explore numbers so that we can understand what this means. Okay, so let's suppose we have two identical numbers multiplying together to give another number. For example, if we have 7 times 7, so we are going to get 79. Okay, so what we want to do, explain what this power means. So this one is going to lead us to understanding that. So actually it's not 79, it's going to be 49. 7 times 7 is going to be 49. Then we know that 7 is a square root of 49. So if we have 7 is equal to the square root of 49. So we all know that. So we can also write this like 7 squared is equals to 49. So all these mean the same thing. 7 times 7 is 49, or 7 is equals to the square root of 49, or 7 squared is equals to 49. Now suppose we found that a to the power p times a to the power p is equals to a. What would this mean to us? When we multiply a to the power p by itself, we get a. What does this tell us about a? So this means that a to the power p must be a square root of a. A to the power p must be a square root of a. So that is what it means. If this is true, if we have a to the power p times a to the power p giving us a. So this is the same as this one which we showed here. That 7 times 7 is 49. 7 is equals to the square root of 49. Same thing here. If a to the power p times a to the power p is a, then a to the power p is going to be the square root of a. Now, however, we can look this is in another way. So we note that a is equals to a to the power 1. And also that from the first rule, we remember the first rule, we said a to the power p times a to the power p is going to be, what we will do here, we are going to add the powers. So it's a to the power p plus p, which is a to the power 2p. Okay, so now we can then say a to the, sorry, okay, let us continue. So what we have here, we said a, if a, so we all know that a is equals to a to the power 1. Now if we have a to the power p times a to the power p, we are going to get this one, a to the power 2p. Now I want us to solve for p. So we know we have a to the power 2p is equals to a to the power 1. So we are going to take the powers here. So we have 2p is equals to 1. So the bases are the same. So we divide by 2, then p is equals to half. All right, now this shows that if we have a to the power 1 over 2, then this must be the square root of a. This must be the square root of a. A to the power 1 over 2 must be a square root of a. So now we can say the power, so let me write this one, the power 1 over 2 means, or it denotes a square root. It denotes a square root. So for example, if we have a to the power 1 over 2, as we have said, is going to be the square root of a. Okay, so now a number raised to the power of our rule will say, so let's just generalize now. This is our rule. What is this rule? I think this one is the rule number 6. So rule 6. So a number raised to the power of 1 over n is equal to the nth root of that number. Okay, so let me explain that. So if we have a to the power 1 over q, so let me just write it, make it bigger, a to the power 1 over q. Sorry, this is going to be the q root of a. So this is the rule. A to the power 1 over q is equals to q root of a. The number raised to the power of 1 over n. Okay, so if we make an example with a, all right, so let me make an example now using a different color. So let's make an example. All right, so if we have a number, we have a to the power half. So this is the same as the second root of a, or so that is the same as not writing, so we may ignore the 2 if it is half. A to the power 1 over 3 is equals to the third or cubed root of a. A to the power 1 over 4 is equals to the fourth root of a. So I'm just giving many examples. A to the power 1 over 5 is going to be the fifth root of a. So generally, what does this mean? A to the power 1 over n is equals to n over a. So this means the same rule. This is a. A to the power 1 over n is the nth root of a. So let me go back to this one. It could be, other books could use a to the power 1 over q is equals to qth root of a. So let me just make more examples here. Suppose we have, so let me just use numbers now to do more examples. So we're doing more examples. So if we have 16 to the power 1 over 4, what does this mean? So this is the fourth root of 16. Now we want to understand what does this mean. This means that we are looking for a number when multiplied together 4 times is going to give us 16. A number when multiplied together 4 times. So this number tells us how many times we should multiply the number. The number is going to give us 16. So the answer here is going to be 2. Let's see if 2 can give us 16. 2 times 2 times 2 times 2. So 2 times 2 is 8 times 2. 2 times 2 is 4. 4 times 2 is 8 times 2 is going to be 16. So now we can say that 16 1 over 4 to the power 1 over 4 is 2. So this is the answer. Or when you like, we can 16 to the power 1 over 4 is equals to the 4th root of 16 is equals to 2, because we have calculated it. Maybe let me make another example. So if we have 81 to the power 1 over 2, this means we have to look for a number when multiplied by itself 2 times gives us 18. A number when multiplied by itself 2 times. So we're looking for the square root of 81, not 18. So a number multiplied by itself 2 times give us 18. So we may not write this 2, so this 2 we may erase so we may erase this, as it is not always necessary when it is a square. It begins to be necessary when it's more than 2, so like cubed root, 4th root, 5th, 6th, 7th, and so forth. So a number then when multiplied it by itself gives us 81. So we are going to get this number is 9. Okay, one more example. 243 to the power 1 over 5. What does this mean? We are looking for a number that when multiplied by itself 5 times give us 241. So this is a number multiplied by itself 5 times is going to give us 243. A number multiplied by itself 5 times is going to give us 243. So you can start by search for this number. So we know 2 to the power 5 is not 2 to the power 5. 2 to the power 5 is going to be what is it? It's going to be 32. So 2 is not correct. So you can do a try and error. Let's see, 3 to the power 5. What do we get? 3 times 3, 3 times 3 times 3, 3 to the power 5, we're going to get 243. So our answer is 3. Then, so we can write this. So let me erase this. I was using this for calculating, so it's not always necessary to show this. So our answer therefore is 3. So 243 to the power 1 over 5. So it means we are looking for the 5th root of 243. And that 5th root is 3. Okay. Thank you.